So these are some questions that are just generic algorithm type of questions, or questions to do with the topic of algorithms that doesn't involve programming. So the first one is a classical question. Define the term algorithm. There are 2 marks for this, so we need to get 2 points. So an algorithm is a sequence of instructions. It's a sequence of instructions, or a step-by-step set of instructions to complete a task. So the 2 marks available are one for saying it's a sequence or a step-by-step set of instructions, and the other one for saying that it's to complete a task. So 2 marks altogether. So you can say that in different words, but as long as it's got the same meaning, you'll be okay. But try to be as accurate as possible. So it's a step-by-step or a sequence of instructions to complete a given task. Okay, so next one we've got is one of the common algorithms that we should know about. So there are a few algorithms we should know about. One of those is the linear search. So the linear search starts on an array, usually. So if we've got an array with several locations in, and let's say we've got numbers, and they're in no particular order, and let's say that we're searching for 21, we would start in this position here, which is 0. So we're going to start in position 0 if we think that this is an index structure. 0, 1, 2, 3, 4, 5, like this. We're going to start at 0 and we're going to say, is the first one 21? And if it isn't, then we'll move on. So we might say that we start at beginning of the array. Or we could say, position 0. Or both. So we compare each element with our search term. So in the example we just did, if we were searching for 21, then our search term would be 21. So we keep doing that. So keep comparing until the item is found. Or we reach the end of the array. Because if we reach the end of the array and we didn't find the number, then it wasn't there to find. And that's, of course, always an option when we're searching for something. So there are 3 marks, one of them for this idea of starting at the beginning of the array, one for comparing and keep doing it, and one for the or idea, that if we don't find it, we'll reach the end of the array and stop in any case. So that is the linear search. So there's one here which is generally about ideas of algorithms, so algorithms, decomposition, etc. So one of the ways we can attack a problem is to break a problem down into a number of subproblems, and that is decomposition. So our label then would be C, decomposition, breaking a problem down into a number of subproblems. And you might have seen the idea of a hierarchy tree for that, where we get several subproblems underneath the main problem like this. It's decomposition. We can make a smaller problem, fix that problem up, fix another one up, put them all together, and we end up with the actual full program. So the process of setting the value stored in a variable, well, that's called assignment. So if we say something like my name equals Fred, you don't need the brackets there, don't worry, we have these. So my name equals Fred, the assignment is this equal. So what that means is literally the variable my name takes the value of Fred. So it takes the value of what's on this side. So that is assignment. Defines the range of values a variable may take. Well, that is data type. So our data types store a certain amount of space or reserve a certain amount of space in RAM to store what we're going to use in that data type, in that variable. So in this case, my name equals Fred would be a string. So, my no equals 21 would be an integer type. So we've got integer. If we had my no equals 21.5, then we've got a real or a float. It's a real data type because we've got decimal places, and 1 equals true, for example, might be a Boolean. So that's taking a Boolean value, just true or false. So they're the main data types you might come across. Okay, so this is the bubble sort algorithm. So on the bubble sort, remember, uses 2 loops, and it loops through until we've been through the whole of this set of loops, one loop times the other one. So we look first across, and the questions we ask are, is this number bigger than this number? The answer to that is no, it isn't. Is this number is smaller than this one though? So we're going to go 3, 1, 5 because we made a swap here. 4, 2. So it's a little bit tricky to fill this in because our brain often wants to do more swaps in one go, but we're trying to restrict ourselves to 1 per time. So then we've got to this stage here now. So we've got whether 4 is less than 5, or it is. So 5 is going to go there, and 4. So we could fill the rest of them in if we want to. It might help us out. And then 5 against 2, well, yes. So 2 is going to come here. And then we start again, and we go back to the beginning of here. So is 1 smaller than 3? Yes, it is. So is 3 smaller than 4? No. Is 4 smaller than 2? No, 2 is, so we're going to put 2 here. And then when we come down again, we're going to go back across this, and 2 will come here. They've already done that for us. 3 will be here, 4, 5, and we will have sorted the array. So that's what they're looking for. There's 5 marks for that. You do have to just keep your wits about you and do 1 swap at a time as you go down on that one. Okay, so here's another question, similar idea. This one talking about the binary search. So binary search is, unlike the linear search, is a divide and conquer style algorithm. So what we do is we look at the middle value, if we can look at a very middle value in an array, and we can here. So we could look at this one, which is the middle value of 3. So we're searching for 30. So we're going to say on a binary search, we'll say that we'll compare 30 with 21, because that's at position 3 there. So it is position 3. And we basically say to ourselves, is 30 more than 20? Is 21 here more or less than 30? Well, because 30 is more than that, we can remove one side of the array completely, because we know that it's in order, so it's not going to be there. So then we look for the middle of what we've got left, which is here. So the middle of that is 31. So let's compare 30 with 31, and that's position 5 still, like that. And we find out that actually 30 is less than 31, so we can get rid of this side. So now we've only got one number to compare to, so we have to compare that. Compare 30 with 27, which is position 4. And we're finished because there are no more numbers. And in this case, we found that 30 wasn't in the array, so it was not there. But we made those 3 comparisons like that. So that's a merge sort question. Don't know whether we've got a merge sort we can do. Yeah, we've got this one. This idea, let's move that over there a little bit, give ourselves a bit more space. So this one's talking about showing the steps for either a merge sort or a bubble sort. So we're going to look at the 2 ways of doing that. So if we decide to look at the merge sort is an algorithm where we separate the numbers into individual single numbers by splitting the lists. So we're going to separate them into, so we'll say we'll separate into progressively smaller lists until just one number. And to do that, we've got 8, 4, 1, 5. So we'd split them into 2 lists, 8 and 4, and 1 and 5. And then we'd split those lists, so we've got 8 on its own, and 4 on its own, and 1 on its own, and 5 on its own. So once we'd split those up, we would then merge the lists back together, but this time in order. So we'll first of all look at these 2 and merge them to one list, and in order they would be 4 and 8. And then we'll look at this list and merge these, and they'll be in 1 and 5. So it's not 48, it's 4 and 8, and that's not 15, it's 1 and 5. So then we will look at merging these lists of 2 together. So we'll ask the question, is 4 bigger than 1? The answer is no. So we'll merge this in a list by putting 1 there. Is 4 bigger than 5? No. So 4 go next. Is 8 bigger than 5, which is the only one we've got there left? No, it isn't. So 5 is going to go there, and we just have 8 left. And that's our merge sort. We looked at the idea of the bubble sort before. So these are the ways of 2 ways of sorting that we need to know about. And then the question here about what's the advantage of merge compared to bubble. So one advantage and one disadvantage of merge. So an advantage of merge is it's much faster to sort large amounts of numbers. And a disadvantage for the merge sort is it's more difficult to program. So it's a trickier algorithm to program. It's more difficult to do that. So that is a perfectly okay disadvantage. So there are other ideas as well. So with the merge sort, it takes more RAM when executing. That's a top level answer, that one. It's that means that we understand that kind of algorithm where we keep splitting to larger and larger amounts of lists takes up more RAM than it does to sort in a linear way like the bubble sort does by just keep going through the list. So that's a top level answer, but either of those are absolutely fine. And the only real advantage is it's much more quick. It's much quicker, not more quick. It's much quicker to sort large amounts of numbers. If you've only got very tiny amounts of numbers, that the difference is not so great. But if you've got very large amounts of numbers, the merge sort is a lot quicker. So there are just a few questions, or quite a few questions there. If you got to the end of that, well done, on the idea of algorithms and some of the algorithms that we need to know.